Hi, I am RUKIAH LATIFF and I am working with Professor Stephen Mikkel, Dr. John Gillam and Professor Peter Kench on the project Optimizing the Production Threshold for Positron Range Modeling in GATE. Positron range improves blurring to positron emission tomography image or PET image. And to remove this blurring, first we need to investigate the character of this positron range blurring. And what we can do is simulate this positron range blurring in GATE simulation software. And in GATE, the production threshold known as range distance is one critical factor that needs to be concerned during simulation. And we need to optimize this factor to eliminate the secondary particle that doesn't contribute to positron range model information. Also, eliminating those particles can significantly lead to computational speed. And we found that there were variations of positron range modeling from previous study, especially the one using GATE, which is similar to what we will use here. And how can this happen? And also none of them discussed or even stated the production threshold used in their study. Therefore, we need to find the optimized production threshold in our simulation to replicate their results. And we hope by doing that, we can move forward to the next step, which is removing the positron range blurring in the image. And here, generally, what we did is we simulate a gallium-68 point source, which is in yellow dot, in a dotted box with different medium density, which is bone with highest density, in water to simulate soft tissue, and lung, which has the lowest density. And the production threshold tested was 0.01, 0.1, and 1 millimeter, which is the max. And from this simulation study first, in figure 1, we found that the energy possessed for gamma, electron, and positron are proportional to the medium density, meaning that the higher the density, the higher the energy particle have. And second, we want to know what is the effect if we set up this production threshold in the dotted or world hierarchy. And here in table 1, we found that the energy possessed for those particles as well as positron range models are proportional to the range distance regardless of the setup location, whether in dotted or world hierarchy. And furthermore, regardless of the setup location as well, these energy results and positron range model are consistent if we're using 1 millimeter production threshold. And finally, what happens if we are not using any production threshold setup? And what happens if we're using low energy positron emitter than gallium-68, which are fluorine-18, carbon-11, and oxygen-15? And to answer this question, here we simulated those radioisotopes in lung, water, and bone. And we found from table 2, the low energy positron emitters, the positron range is consistent with and without production threshold. But for gallium-68, which has higher energy, the positron range reduces with 1 millimeter production threshold setup. As the gallium-68 is our radioisotope of interest because its severe blurring effect on the image, and we compare our result with Sultanidis 2011, and we found that our result is acceptable. And to wrap up, the production threshold plays important role in modeling the positron range. We found that 1 millimeter range distance is the optimized production threshold setup, in particular for gallium-68. Thank you very much.